Okay, now if you place capacitors in series, okay, they add like parallel resistors, okay? You actually get less capacitance, and I'll show you why here in a second, right? Okay, so the formula is 1 over the capacitance is 1 over C1 plus 1 over C2 plus 1 over C3, okay? And the reason for this is that this is all three of these are going to act like one capacitor. And the idea is this, is if I say I make this the positive side, right? There'd be positive Q here and negative Q there, right? This little piece of metal right here is an isolated piece of metal. So we simply have an induced charge. If it was initially not charged, if there's negative Q there, there has to be positive Q here, right? And again, negative Q and positive Q and negative Q, right? Now, the outside world sees only Q and Q. And so there's Q amount of charge on there, right? Okay, but it's the same charge and it's spread out through three capacitors like that, right? It's not spread out, but it's on these three capacitors, right? And the total voltage is going to be, because remember capacitance is what? Charge divided by voltage, right? So voltage is charge divided by capacitance, right? Okay, so the total voltage across this circuit, let's say we hook voltage source there, right? That's at some voltage V, right? That total voltage is just whatever that charge is, right, over C1 plus whatever that charge is over C2 plus whatever that charge is over C3. The total voltage will be whatever the voltage is across this plus whatever it is across this plus that, right? It's a series circuit. We would just add up the voltages, right? These are, by the way, these charges are all the same, right? But let me just say that the voltages across each capacitor will not be the same because they have different capacitance. Smaller capacitors will have larger voltages across them, and larger capacitors will have smaller voltages across them. But every capacitor will have the same charge on it, right? Because the charge has nowhere else to go. It's a series circuit. Okay, so now we want to get the capacitance, right? Capacitance is Q divided by V, right? So the capacitance will be whatever that one charge is, right, divided by the voltage, which is this, right, plus Q over C2 plus Q over C3, right? Because we're talking about the overall capacitance, right? So this is the overall voltage, the sum of all the voltages, right? And then you can see that the Q's all cancel out, and you get C is 1 divided by 1 over C1 plus 1 over C2, 1 over C3, which is the same as what's in the data packet. This is one way to write it. This is another way to write it, which I prefer, but I understand why they did it this way. Okay? Yeah. So the reason you have less capacitance is that you have one charge, right? And the voltage is split up, right? And so therefore there's less charge. All right.